Okay, so today we're going to be talking about the 2022 Amc 12B problem 25. In my opinion, this problem really wasn't that hard for problem 25. It's just really time consuming, this is probably why most people didn't solve it during the test. But okay, let's start. 4 regular hexagons surround a square with side length 1, each one sharing an edge with the square as shown in the figure below. So as you can see, we have one hexagon here, which has the square side as one of its sides as well. And then we also have 3 other hexagons just kind of rotated around. The area of the resulting 12-sided outer non-convex polygon, it's a mouthful, can be written as m times the square root of n plus p, where m, n, and p are integers and n is not divisible by the square of any prime. What is m plus n plus p? Okay, so the first thing I thought when I was looking at this problem was, we could probably just chord bash it and use Shoelace theorem, or Shoelace formula, but we have 12 points, so we would have to write 13 points in a column, and that's just kind of a lot of computation that I wouldn't really want to do. So then I looked for a shortcut, and what we can actually do is connect each of these points like so. And the reason why this makes the problem a lot simpler is because now all we have to do is find the area of each of these 4 hexagons, and then also add one for the square in the middle. And to find the area of each of these hexagons, we can draw this segment here. And then the area of each of these hexagons, well, notice that we have 2 trapezoids, and they share one base, and then both of their other bases are going to be length 1. So we have 2 trapezoids with the same bases, and we also know the height, which is going to be root 3 minus 1. So all we have to do is actually find the length of this segment here, because if we know that, we can add it to find the area of each trapezoid. Okay, and how can we find this length? Well, one method we can use is just chord bashing it. All we have to do is find the coordinates of each of these points to find the length of the entire segment. And actually, we only have to find the coordinates of one point because it's symmetrical, so you can just multiply it by 2. So let's say the center of the square is 0, 0. Then we want to find the equation of this line here and this line here. So we can find the intersection of those lines, which is the point here. So let's start with this point right here. So we have to move 1/2 in the positive direction, so this would be 1/2, 0. And then we have to move to the left, root 3. So that's going to be 1/2 minus root 3. And then the y-coordinate is just going to be 1/2 up. So this first one is 1/2 minus root 3, comma 1/2. Let's see this next point here. Well, again, we have to move 1/2 in this direction, and then root 3 over 2 to get to the center, which is the x-coordinate. So this will be 1/2 minus root 3 over 2. And then this entire length is going to be 2. So half of that going up is just going to be 1. So the y-coordinate of this point will be 1. So that's our first line, the 2 points. Now let's do our other 2 points here. So let's start with this one. Well, this entire length is 2, and we want to move half of that in the negative direction. So this x-coordinate will be -1. And then to get the y-coordinate, we move 1/2 down. So this is 0, -1/2. And then √3/2 up. So √3/2 minus 1/2. I hope you can see that. I'll just write it bigger. It'll be -1 √3/2 minus 1/2. Okay, and then finally we want this point here. And so we want to move 1/2 in the negative direction on the x-axis. So this will be -1/2. And then 1/2 down, √3 up, √3 minus 1/2. So those are all 4 of the points we need. Now let's actually figure out the equations of each of these lines. So let's start with this one right here. So our slope is going to be 1 minus 1/2, and then this will be the 1/2 in the x coordinates cancel out. We get -√3/2 minus -√3, which is going to be plus √3, and that's going to just be √3/2. So this will be 1/2 over √3/2, which is 1 over √3, which is √3/3. So we can write our equation as √3/3x plus b, and we want to solve for b. So we plug in one of these points, let's say this one. So 1 is equal to √3/3 times 1/2 is √3/6 minus √3/3 times √3/2, which is 1. Well, these cancel out, so we're left with -1/2. And then plus b. So b is going to be equal to 3/2 minus √3/6. So our first line is going to be y equals √3/3x minus √3/6 plus 3/2. This is our first line. Now we have to solve for our second line. So again, let's solve for the slope. We subtract the y-coordinates, we get √3/2 on top. Subtract the x-coordinates, you get 1/2. So this is √3. Again, we have y equals √3x plus b. Plug in one of the points, let's say, it doesn't really matter, let's just use this one here. So y-coordinates √3 minus 1/2 times is equal to √3 times -1/2, so -√3/2 plus b. And so b is going to be equal to 3√3/2 minus 1/2. And so our second line is going to be equal to y is equal to √3x plus 3√3/2 minus 1/2. Okay, now we just have to solve for the intersection. Yeah, as I said, it's a lot of computation. So set them equal to each other. I'm going to just move the paper down so you can see it. √3/3x minus √3/6 plus 3/2 is equal to √3x plus 3√3/2 minus 1/2. Let me just check if this is right. I don't want to spend 10 minutes computing a wrong equation. I think it should be right. Okay, and now we just have to solve for x. So say let's move the x to this side. We get 2 root 3 over 3x, and then that gets rid of this term and this term. Plus move the 1/2 to the other side, you get equals 2. And then also move this over. So negative root 3 over 6 minus 3 root 3 over 2. What is this? Well, this is the same as negative, or let's just compute the positive version. This is 9 root 3 over 6. So that would be 10 root 3 over 6, which is 10 root 3 over 6, which is 5 root 3 over 3. So minus 5 root 3 over 3 plus 2. And then we just solve for x, I guess. So multiply both sides by 3. We get 2 root 3x is equal to 6 minus 5 root 3. X is equal to 6 minus 5 root 3 over 2 root 3. And this is just like x is equal to root 3 minus 5/2 by just rationalizing them. So that's our x coordinate at this point. Now notice that this is going to be negative because, well, it's to the left of 0, 0. So we take the absolute value of this and multiply by 2 to get this entire length, because the absolute value is just basically going to be the distance from here to the center, and we want the entire length, so that's just going to be times 2. So the absolute value of this, since it's negative, it's going to be 5/2 minus root 3. Sorry, you can't really see that. And then times 2, this will be 5 minus 2 root 3. So this length here is 5 minus 2 root 3. And we have everything that we need to solve this problem. So we know the height of this entire thing is root 3 minus 1. So I'll write that here. Root 3 minus 1 times the average of the bases, which is going to be 1 plus 5 minus 2 root 3 is 6 minus 2 root 3, divided by 2 is 3 minus root 3. That's going to give us the area of the hexagon. But we have 4 of these hexagons, so we multiply this by 4. And then finally we have this square, so it's going to be plus 1. And finally we just have to expand this. So what is this? 4 times 3 root 3 minus 3 again, plus root 3 plus 1. This is 4 times 4 root 3 minus 6 plus 1, which is 16 root 3 minus 24 plus 1 is minus 23. And we want to find n plus n plus p. So 16 plus 3 minus 23 is negative 4, and that's going to be our answer, which is answer choice B. So I hope you enjoyed this video. I formatted it a bit differently this time. Usually I copied it down on a piece of paper. But anyways, so be sure to like, comment, and subscribe, and leave a comment about what you would like to see next. See ya.